Alright, so 6.6, we're going to use properties of trapezoids and kites.
Wait, kites?
Kites,
Like
yeah.
flying things?
Yeah.
Oh, that's sick.
So a trapezoid is a quadrilateral with exactly one pair of parallel sides. Each of the parallel sides is called the base, and the non-parallel sides are called legs. The base angles of a trapezoid are two consecutive angles whose common side is a base. So we have base angles B and C, and then we also have base angles A and D. So the difference between a trapezoid and a parallelogram is a trapezoid only has one pair of parallel sides. And a trapezoid has how many? How many pairs of parallel sides?
Oh, two.
Two. Two pairs. This one only has one pair.
So parallel has two, trapezoid has one.
Yep. Did you get it? So if the legs of a trapezoid are congruent, the trapezoid is an isosceles trapezoid. If the legs of the trapezoid are congruent, the trapezoid is an isosceles trapezoid. So remember, the legs are the ones that are not parallel. So if we look at the legs here, this one and this one, are these two lines parallel? No.
Oh. Yeah,
Oh, no, no.
But in isosceles trapezoid, the two legs are congruent. So now we have some theorems. If a trapezoid is isosceles, then each pair of base angles are congruent. So if a trapezoid is isosceles, then each pair of base angles are congruent. So here we have A is congruent to D, and B is congruent to C. The next theorem states if a trapezoid has a pair of congruent base angles, then it's an isosceles trapezoid. So if a trapezoid has a pair of congruent base angles, then it's an isosceles trapezoid. So we know if angle A and angle D are congruent, then it's isosceles, so then we know that AB is going to be congruent to CD. And our last theorem states a trapezoid is isosceles if and only if its diagonals are congruent. So remember, if and only if means that this is a biconditional statement, so the same thing works in reverse. A trapezoid, so if a trapezoid's diagonals are congruent, then it's an isosceles trapezoid. And if a trapezoid is isosceles, then its diagonals are congruent. So you have its diagonals. AC is congruent to BD. So these are all theorems about trapezoids. All right, next we have the mid-segment of a trapezoid, which is the segment whose endpoints are the midpoints of the legs. So the mid-segment of a trapezoid is the segment whose endpoints are the midpoints of the legs. So here, this line is our mid-segment, because it's the midpoint on this leg and it's the midpoint on this leg. The midsegment of a trapezoid is parallel to each base, and its length is half the sum of the lengths of the bases. So it's parallel to each base, and its length is 1/2 the sum of the lengths of the bases. So if we add the top base and we add the bottom base and divide it by 2, then it would be the length of our midsegment XY. So if we add the top of the trapezoid and the bottom and divide it by 2, we get the length of our midsegment of the trapezoid. So let's say BC had a length of 5 and AD had the length of 9. What would the length of XY be? What would we need to do? 1/2 times 5 plus 9. So what's 5 plus 9? 14. So what's the length of XY? 7. Okay, so this was the mid-segment theorem for trapezoids. Next, we're going to go to kites. So a kite is a quadrilateral with exactly 2 pairs of consecutive sides. So we have side AD and AB. Those are consecutive, meaning they go one right after the other, and those 2 are congruent, and then BC and CD are consecutive, and those 2 are congruent. So this makes a kite. Like the ones you fly in the sky. So now I have some properties of kites. The first one states, if a quadrilateral is a kite, then its diagonals are perpendicular. What does it mean to be perpendicular? Crosses at 90 degrees. So the diagonals here cross at 90 degrees. The second one says, if a quadrilateral is a kite, then exactly 1 pair of opposite angles are congruent. So only 1 pair of opposite angles are congruent. So B is congruent to D, but A is not congruent to C. So B and D are congruent, meaning they're the same thing, but A and C are not the same. Alright, so now we're going to do some examples. Example 1, find the measure of angle A. So we're looking for this angle here.
80.
Raise your hand if you think it's 100. Raise your hand if you think it's 80. It's 80. Because we know that the base angles are the same, so this angle, although this trapezoid is sideways, this one and this one are base angles, so this angle, angle D, is also 100. And since these two lines are parallel, and this is our transversal, angle A and angle D are consecutive, are same side interior angles, so they add up to 180. So angle A is 80 degrees.
So you subtract by 180?
Uh-huh.
Oh.
So we do 180 minus 100. Good job, guys. What would angle B be?
80.
80. So this only works in an isosceles trapezoid. So here, since we have these tick marks, we know that it's an isosceles trapezoid, so that's how we know that angle A is 80. Let's go to the next one. What type of trapezoid do we have here? What type of trapezoid? Isosceles, because we have the legs are congruent. We can tell by the tick marks. So how do we find the measure of angle F?
Is it going to be, you have to do 180 minus 49?
Perfect. 180 minus 49. And what do we get?
151.
131. So angle F is 131. What would angle E be? 49. What about angle G? 131. So if we add up all four of these angles, what are they going to equal?
360.
360, which that's what a quadrilateral is supposed to equal. Okay, ready for example 3? So KB is 21.9 and MF is 32.7. Find FB. So this long one here is 32.7. And this short one is 21.9. $32.7 minus 21.9. Because we know that this part is also going to be 21.9. So in order to find FB, this tiny part, we just need to take the total and subtract it by the part that we know. So what is 32.7 minus 21.9?
What? Yo, I have 7 minus like 2. Yeah,
What is it?
10.8.
10.8. So the length of FB.
So wait, why would you minus it?
Okay, because we know that this part is going to be the same as this part. So this green line is 21.9. The whole thing from F to M is 32.7. So the whole thing is 32.7, and part of it is 21.9. So to find the other part, we need to subtract the part that we know. So we have to subtract 21.9 from 32.7. Because this part, this yellow part now, we said is 10.8. So if we add 10.8 plus 21.9, we get the 32.7. 10.8. Okay, ready for the next example? That's the spirit. Example 4. In kite ABCD, the measure of angle DAB is equal to 54 degrees, and the measure of angle CDF is equal to 52 degrees. Find the measure of angle BCD. So we're looking for this angle here, BCD. And it gave us that DAB is 54 and CDF is 52. What can we do first? What type of shape is this? A kite. So what do we know about kites?
That one pair is good.
Congruent to another pair. So what's going to be congruent?
That's 52.
BC is congruent to?
Dab.
Well, we're talking about segment BC.
Oh, BC is congruent to AB. Or wait, is it? Oh,
No,
BC is
BC
congruent
is
to AB.
CD.
CD. BC is congruent to CD.
Yeah.
Is it because it's consecutive?
Yes.
Okay.
And we know that it's not congruent to AB because it's clearly shorter than AB. So what's AB going to be congruent to? AD.
Also, how do you know where to put the 52 and 54 right away?
It tells you.
So it tells us that angle DAB is 54. So in order to tell what's 54, we start at D, we go to A, and then we go to B.
Oh.
Okay, what do we do now?
We minus 180 from 52.
It equals 108.
Wait.
You multiply 52 by 2
Why?
because BC is congruent to CD and then they both would equal.
You add,
So 52 is talking about this angle here.
you add the 52 and the 54.
Why did we add those?
I don't know if it looks like that's what the answer would be.
So we're looking for BCD, this yellow angle.
The way that I did it is I knew that B angle CDF and FBC are the same
How did you know they're the same?
Because they're
because the
congruent.
opposite angles are on the kite, whatever.
Because they're consecutive angles.
What type of triangle is this here?
Triangle.
Isosceles. So if this angle here is 52, what's this angle here going to be?
52.
52.
And then I added those and subtracted from 180 since it's a triangle.
Perfect. Since this triangle, the blue one, is a triangle, we know all three angles are going to add up to 180. So we have 52 plus 52 plus, let's call this yellow one angle X, because that's what we're looking for, is equal to what?
104.
180. All three of them add up to 180. So 52 plus 54, 52 plus 52 is
104.
104. So we're subtracting 104 from both sides, and we get X is equal to
6. 86.
Yeah.
76.
76.
Bro, what is you saying, bro? You thought it was like 139.
I didn't see the answer.
So is that our answer?
Yes.
So angle BCD is equal to 76 degrees.
So it's 52, the other side is 52 because it's on the same line, right?
Because this is an isosceles triangle here. Okay, so ready for the next one? Last example. Austin, you want to read it for us?
Yep. It is, Lucy is framing a kite with wooden, is that like towels with wood?
Yeah.
Dowels. She uses 2 dowels to measure 18 centimeters, 1 dowel that measures 30 centimeters, and 2 dowels that measure 27 centimeters. To complete the kite, she needs a dowel to place along KL. She has a dowel that is 36 centimeters long. How much wood will she have left after cutting the last dowel?
Okay, so our goal is to find what KL is. So, how do we find KL?
Would you like take like
You would add all of them.
Bro, Chloe, that's what I was about to say, dog. Except like not all of them. You would add the 18 and 27
And do what with it?
and like put them into KL.
Divide them into half.
Times it.
What do we look?
Would
Times
you,
by
wait,
one.
would you add 27?
Okay.
18 equals 30?
KL equals.
Is it an
equals
isosceles?
27.
So, it gave us the side lengths, and we need to find a side length, right? So, we don't do 180 because that's only when we have angles.
So the 30. It's equal to 30 because it's more triangle.
Wait, yeah, I was about to say, is it 30?
Where are you?
Oh.
This JM is 30. So, what is this part of JM?
15.
15.
15. So then the other part's 15.
So, then the other part is 15 too.
Oh, because it is
So then KL would be like
30.
something like, yeah, 30. Yeah, like you would just take the JM and put it like that.
Because it's, oh, wait, no, it's nothing. Okay.
Is it 45?
Shut up, dog.
That
How'd
would
you
be
get
34.
45?
76.
Yeah, I got 80.
How'd you get 34?
Because 27 plus 15.
I did 27.
Oh wait, that's not even 34. 33.
That's not 30.
Oh, the answer's 30 something.
What do we know about the diagonals of a kite?
They bisect. I mean,
Bisect
they're
at 90,
congruent.
might be at 90 degrees.
They intersect at 90 degrees. So they're perpendicular. So this is a right angle here. This is a right angle here.
It's 180.
So
Nice one, Smarty.
if we have a right triangle, how do we find this side of a right triangle?
90.
Well, no, because the 15 would be, it would also be 15 right there.
How do we find the leg of a right triangle? If we have two and we need to find one, what do we need to do?
Oh God. Divide by 2.
Oh, Pythagorean.
Pythagorean theorem.
God, a baby.
Oh.
Okay, so looking at this triangle here, what's our a squared gonna be?
18.
15.
15.
X.
So 15 squared plus, what's our b?
15.
No one.
X squared.
15.
X squared. We don't know what it is yet. And what's that gonna be equal to?
18.
18 squared. So what's 15 squared?
130. 30.
No.
20, 125.
No, it's like 200.
125.
It's a
225.
It's a big number.
225.
Wait, I got
225.
I got this.
225 plus x squared. What's 18 squared?
Wait, I got this.
324.
Yeah. Out of these.
So now we need to subtract 225. And we get
91.
99.
I think. Someone do that.
Right? 99?
Yeah.
And then you would like do 99. Yeah.
So x squared is equal to the square root of 99.
But
What's-
we just did all that not to even find the answer, just to find one side.
One part of the answer.
See, that's why I didn't be answering some of the questions on the test.
How do we simplify the square root of 99?
33.
9 times 11.
Oh, 9.
So 9 splits up into 3 and 3. So we can take 3 square root 11. So this part here is 3 square root 11. So now we need to find this part down here.
What?
This one.
We're not done.
We're not done.
Wait, what part do we need to find?
The red one in the middle. So what can we do to
The same thing.
the same thing? We do the
Oh,
Pythagorean
yes.
theorem again.
Just square root
Oh.
27 instead of 18.
Right, so we have 15 squared plus x squared is equal to 27 squared.
Oh,
This is a different.
fours.
You guys do it.
What is 27 squared?
The number.
Yeah, what'd you say?
729. So now we subtract 225 from both sides. So we get x squared is equal to 504. What do we do next to solve?
You add square root.
Square root both sides.
So we get x is equal to the square root of 504. How can we simplify the square root of 504?
Eight.
Do something with 8.
Two.
Two.
2 and what?
2 and half of 504.
252.
So now how do we break up 252?
2 again.
And?
And half of
1,
252.
2, 6.
What?
Wow.
How do we break up 126?
There-
6?
Two?
No. 2, 26 if you do 6.
2 and 63.
But you could have done 6.
3 and 21. And 21.
21 and then 3 and 7.
3 and
And
7.
then that's like the final thing.
Okay, so we have a pair of 2s and a pair of 3s, and we
then,
have
like,
a
that's
2
even a
and a
7.
7. 6 square root 14. So this part here is now 6 square root 14. So how do we find KL?
3
Do you
squared
six
out
square
plus
root
6
14
squared
times
14.
Bro, why is this so hard?
3 square root 11 plus 6 square root 14.
9 square root 27.
Wait.
We can't combine
Wait,
those.
let's carve
So
out
this is our
that.
answer. Because it's asking us for KL, the whole line. So we found that this part of it is 3 square root 11, and this part of it is 6 square root 14. So we just add those two together.
Wait, that's the answer?
That's the answer.
The answer is,
Because we can't combine 3 square root 11 and 6 square root 14, so we leave it like that. I'm pretty sure when this example was made, they used a calculator, but it's fine. We can do it without one.
Would that ever be on the test?
Something like it. But now you know how to do it.
Yes.
Yeah, after 2